Hello, everyone. Today we are having an InterSystems full stack contest kickoff. And my name is Evgeny Shvarov. I'm an InterSystems developer ecosystem and startup manager. And today we have the following agenda. So we invite everyone to talk about the full stack contest on InterSystems developer community, where I invite developers to contribute open source solutions that use InterSystems technology to build full stack applications. And this contest is not like general purpose. It is focused on solving one of the global challenges, is climate change and global warming. And today we have a guest speaker, Ainar Abdrakhmanov, who is a co-author of the course of 4 waves that is focused on tackling this problem and revealing the issues with climate change. And also Ainar is founder of Longevica startup. So actually I pass the floor to Ainar to give an intro and give us a talk. What are the key challenges we are having with climate change and global warming, and why is this important? Ainar?
Yeah, thank you. So, hello everyone. I guess I have 15 minutes, yeah?
Yes, Ainar.
Cool. So I prepared a few slides. I just try to show them now. So when we talk about the climate change, it's a lot of things behind it, yeah. And one of the most important and most challenging. By the way, do you see my presentation now or not?
Yes, we see the slides. Yes.
Okay, most important megatrend. Yes.
Yes, most important megatrend.
Sure. Thank you. Cool. So when we discuss about the climate change, it's a lot of controversial information, a lot of speculations, a lot of misunderstanding, and actually huge concepts. Yeah, to understand what is it, climate change, even person well educated and have a lot of knowledge about the physics and statistics and math and data, everything. It's a very challenging concept. And today I want to present one concept which we created, and technically I helped to build this course. And if you're interested, you can open it in 4waves.org, www.4waves.org, and go through it. But today I will share the most important and the biggest insights behind it. So, and I hope, actually it's a goal, 4 waves will help you to realize where we are, why we're here, just in 15 minutes. And it's a big challenge, but also understand where we go as a humanity of the civilization. So mega transition started in 17th century and will finish in this century. And what is it, this mega transition? As you remember, we all started in agriculture. We most of the time, people in this 17th century, 18th century, they spent to build, to seed and make a food. So that was the basic things what people did, yeah. But then something changed. These 5 mega transitions start to involve. First, it's a demographic transition, then is energy transition, then urbanization transition, industrialization, and dietary transition. All these 5 transitions started in different time, in different areas, but they always the same by results. So different start, same destination. And this is the most interesting insights. Anytime when countries started these 5 transitions, they always do by this, they always go through the same pathway. And that why 4 waves? Because we could count for countries when they start these waves and look to them. So Western countries, by Western countries, I mean the all Europe, North America, Australia, New Zealand, and Japan, that times Russian Emperor, US, Russia, and some other countries, but mainly it's a Western. It's we call it as a Western in our history, yeah, and everything done by them. So, and they started first, and they already finished this transition. So, second wave, of course, biggest one is China, Latin America, Gulf countries, North Africa. They started in 1915, 16s mostly. And the third waves is countries just started it in 1980. So it's India, Bangladesh, Pakistan. It's almost 2.5 billion people. And third wave Sub-Saharan Africa, they just started this 4 waves transition. They just started. And one of the most simple results of outcomes of this concept of break down the countries to this, you just realize simply all countries, they have totally different goals now. First wave countries, Western countries, you could put strategies like reduce carbon emission. But the interesting thing is 65% of all carbon emissions done by Western countries in total. So it's not important what the country is doing now, it's important what is cumulatively is done. So, and the countries, Western countries already build the infrastructure, electricity, dietary, everything. And now they could start, they transition to the, for the electric, the sun, this wind, and all energy, what they could renew, yeah. So, and one of the, another interesting results, it's from GDP per capita. So fourth wave countries now, they have a $2,000, it's a GDP per capita. And the first wave countries in average have 40,000 GDP per capita. So you also interesting thing from GDP per capita point of view is how much things they could buy to this money. So imagine Sub-Saharan Africa just start this transition. They just start this transition. And almost 1.5 billion people will go through this, and they will live in the standards of life what Western countries explore. I also want to highlight the most important thing. They not build these standards. It's not standards built by Western countries. It's a very natural for humans. It's a very natural. They just started earlier than others. So second wave countries, yeah, like for example, interesting with China, they produce concrete the same volume as the whole world built in the whole past of the history. And why so? It's because a lot of people, they need cities, they need these buildings. And and you see it's from example, like Our World in Data. Maybe you heard about this website. We will back, by the way, to this website. So, and it's clearly how to compare, yeah, where the countries is, where they are now from the history perspective. So, and every country goes from the start, acceleration, deceleration, peak, and degrowth. And Europe and Western countries now, they very clearly in the growth stage. And it's not mean they will, the lifestyle will decrease, etc. It's they just need less and less. And demographic, for example, the birth rate is lower from 2.1, and so that means it's a very natural decrease of the population. So China is just in deceleration, yeah, just not even get the peak. And India, we will see the hockey stick, and Africa. So from sorry, some Russian words here. So we start with the 6 kids.
Ainar, just a second. If you change slides, we see only the first one, most important megatrends.
Oh yeah,
we do, yeah.
Sorry, my fault.
No problem.
because I show you the slides, you know. Now you see
yes, actually we follow your the pictures you perform with your words. So yeah.
Yeah. So 5K transition, yeah, I showed the. This is why for waves. This is the most important slide. If you will just remember this one, just remember this slide. This is why for waves concept. And this is GDP per capita, show it already. Blah. So this is the demographic transition. We always start with the 9 to 6 kids, and we always finish with 1.8. It's all countries go to this pathway. There are some exclusions, like for example, Egypt. They still have 6, even their second wave. But this is just one of the few exclusions there. So, okay, this is a lot of Russian slides. One second. I just want to show you the last one. And back to this slide. Okay, you see this? Yeah, GDP per capita.
Yes.
So, guys, last thing what I want to say, if you go to this concept with the 4 waves, that's basically mean, and this is pure logic. You don't need to be like scientist. It's a pure logic. If all these countries already build the standards of the life and they explore it, now every country moved to this, every country, like urbanization. They start with a 10% urbanization, they finished with a 90% of urbanization. The dietary transition, they start with 1,500 kilocalories per day, and they finished with a 3,300 kilocalories per day in everywhere, in all countries. And the industrialization, they start with a very, very low kilowatts per capita, and then they finished with almost, I will show you it. Just one second. 30,000 kilowatts per hour. So this is insane. And urbanization, I already told, it's from 10% to 90% energy. And what simple conclusion we could make? If we have a half of the population not finished yet, that just started yet, like a 3rd wave and 4 waves countries, and is 4 billion people there, 4 billion. Imagine this is 4 billion and they just started. And we have China, 2nd wave countries, they almost finished, but not finished yet. And we have just one 1st wave, they just finished this 4 waves transition. So we can finish with a very simple conclusions. First, United Nations projections 5 years ago with their reports of reduced till 2050 carbon emission was false. They know it from the day one. They know these figures, and they just a year ago they published, finally, God bless them, some of politicians finally get this responsibility. They shared this information before the summit, and they showed it's absolutely impossible to be carbon 0 emission till 2050. It's impossible. This goal, we can't achieve. It's impossible to achieve. And the simple simple and clear answer why it's not because like bad politicians and a lot of problems or we have a problem with economies. It's just because 2nd, 3rd, 4th waves, they will continue to do this, and it's impossible to stop them. Very clear. Paris Climate Congress was when Indian representative, he tell us, why you get this opportunity to finish this, to build infrastructure, energy, dietary transition. You already did it. Why you don't give us this opportunity? And they all build it in the coal. All this build it on the coal. And India now want to do the same. Africa want to do the same. So, and this is a very simple outcomes, very simple conclusion why it's impossible. And most probably we will increase almost 2 times. This is also insane figures. It's hard to imagine for this 50 billion CO2 emissions per year, we not just decrease it to the 0, we most probably will increase it. For energy in Africa, we need 10 times growth in Africa, and 2 times in total for the dietary transition. We need 2 times more food to live in the standards what we already explored in the first and second wave. And this is, I think we could finish here. And I want to say data in the world of climate change was absolutely crazy outdated. So, for example, if you go to Ideas for World website and you can open the reports where they get this data, in 30%, 40% of this data, you will find out it's a Václav Smil. Václav Smil is our idol. We love him. Founder of this idea of 4 waves. He's kind of student of many years, and the same as Bill Gates. He always recommend all Václav Smil books. They are good friends. But Václav Smil get this data one by one from all departments, from all the worlds, just to one person. He even don't have assistant. And when you know one person give data with for our world in data, then every person, every journalist, every magazines, every like a blog post, they share this data. You feel like this is not sustainable data, and we need some new concepts how we can collect data, how we could share data. And I think only when we will have the right data in climate change, we will start really fast moving with our understanding, and we will start to be much more proactive than now. Thank you.
Ainar, thank you so much. Colleagues on the call, do you have any questions to Ainar? And before you start, I have one. So Ainar, what would you suggest for developers to focus on? I mean, in this contest. So
I think collecting data, parsing data tools from most trustable websites could be interesting opportunity from my perspective, because now it's really hard to find the data. For example, FAO, United Nations, World of Bank, all of them, they have a very different methods of sharing the information. And when we did our course, for example, 4 waves, we spent like numerous hours to get the data, because we, in every claim what we did in our course, we have at least 2-3 links, because we want to make this course fully based on data. And I could say data is like a huge problem. I think world really don't know what's happening in real. And also we did a few podcasts, and with one of them he called it in the United Nations World Bookkeeper. It's his kind of name last 20 years. Why everyone call it in United Nations World Bookkeeper? Because he know most of the resources, where they based, who they own now, how they explore it, and how they use it, etc., etc. But again, when I realized it's just one person have a name of the World Bookkeeper, it's still like a huge trust to him. I'm admire him, but you know, when we live in the data on the world of data, it's really hard to imagine when one person will have this power. I think it should be power of community of developers who extract data, collect data, and combine scientists, and they together build more sustainable methods of collecting and showing data.
Yeah, great. Thank you, Ainar. As I figured, this can be encouraging for developer, because as if the problem is a global challenge, like climate change is a global problem, global challenge, very few people do it like for real. Like and very few people really make an influence here. So this is an opportunity for you developers. So I mean,
Yeah.
You really can influence the problem. Yeah.
And I think, Evgeny, also it's important to challenge authorities, to challenge big names. For example, Elon Musk always do mistakes in all his Twitter about population. It's like a very classic mistake of Elon Musk. He always tell, we have a problem of decreasing population. Yes, it's true only in the first wave countries, and a little bit in the second, but all rest is booming now, and it's far away. We're far away from the decreasing population now. So that's why there are no authorities, no heroes. We could challenge them with the data, with the most interesting collection of data and insights, and every person, every developer could make a huge difference.
Mm-hmm. Ainar, thank you so much. I think developers, you see the opportunities now. Even by myself, I see that if I would participate, I would like try different sources and compare them, and we'll see how truthful they are. Any questions to Ainar? Okay, there are no questions. Ainar, thank you so much for your passionate speech, and it's very important. I think everyone who will watch this. Yeah, Alex, please go ahead.
Sorry, quick question. It was just, what kind of data sets would be really interesting for you? So without any expertise in this area, if I just rattled off rainfall, deforestation, tidal change, temperature, solar influence, is anything in that area useful? Or do you have a sort of an article we could go to get some direction on what kind of data types would be useful for your research?
Deforestation, one of the most interesting, Alex, especially because of the last year huge summit, yeah, where the world leaders agreed to stop deforestation. And when you want to stop something, you need to start to count it very carefully. And deforestation data could be very interesting approach. And also, I think the food itself, food in general, by creating the massive data where the food produced, how it's transported, and why it's a big problem, and why food will be a big problem in very near, like 10, 15 years. And behind food also a lot of information. So what I'm suggesting, the areas where there are a lot of information, but they are structured in very different ways. So another, maybe third could be the water itself. Water itself is also a huge problem, and the energy itself, it's a huge problem. And also interesting, energy by renewable and current methods of energy, and comparing them, and to show why it's impossible to live only in the renewable. And it's also, we did it in our course. When you start to compare it, it's like, it's insane idea to put strategy only for the renewable. It's impossible. People will just sacrifice with the, they will follow just to the renewables. And maybe also some myth about, for example, electric cars. It's also a big myth now, like we will use only electric car. We did one podcast with another guy, and he told us like lithium will have enough only for 200 million cars. That's it. And we need 1 billion and 500 million car more till 2050. So, and when you compare this data and you show them in one snapshot, it's always like blow your mind, and you feel like, wow, why mass media is so insane? Why they don't follow the real figures? And because it's hard. Imagine how many hours you should spend to build this beautiful design, beautiful cubic data. Then, like, we just did it with at scale in Longevica with the InterSystems Hub. It's like crazy hours you need to do this. So yeah, guys, I think it's, and again, if you have time, you just go to the 4waves.org and go through this. It's a 8 videos, 15 minutes video, all free, like all data behind them, and you could know a lot, and it's will be inspiring you.
Yeah, thank you, Ainar. Thank you.
you.
This is very inspiring. Thank you. Thank you.
Bye bye. I'm leaving now. Yeah.
Maybe a last chance for questions. Any more questions for Ainar? No questions, Ainar. Thank you so much.
Good luck, guys. Good luck.
Yeah.
Thank you. Bye bye.
Yeah. Bye. So, colleagues, I think we have a clear problem. It's not only for InterSystems developer ecosystem. It's like a really global challenge, and I think the input, if you just introduce anything that is related to data sets and expose these data sets with InterSystems tools of how to deal with data. So even this will be very helpful, not only for developer ecosystem of InterSystems, but maybe some for this global challenge of climate change. And now I invite Tim Leavitt to reveal us the new tools and libraries you can use to build full stack applications with InterSystems technology, because just will remind you that this is a full stack contest. So we invite you to build full stack applications with InterSystems backend and some other tools. And Tim, please pass the floor to you.
Yeah, so I was talking to Evgeny last week at Global Summit, and it's like, oh, there's a full stack development contest, and I just happened to have released a couple new really helpful full stack development tools on the Open Exchange. So it's kind of a natural fit to advertise those, and I think I would love to get your feedback on them. Those tuned in, those on the developer community may watch this later, maybe in a more convenient time zone. So yeah, the short of it, my screen's sharing, right? You can see the article.
Yes, we see myself.
Posted.
Yeah.
And you're muted. It says I'm screen sharing. It's fine. So there are 3 new packages, and then a 4th that kind of demonstrates how they all fit together. Really, at the heart of all of this is a new package, isc.rest. And the basic idea there is that providing a REST API to your data should be just as easy as, extend a class, override a parameter, and say how you want security to be handled for that resource, which is a decision that you need to make up front. So for all of these, there's actually pretty good documentation in GitHub. I just found out at Global Summit that there was one customer using the predecessor package to this, apps REST, and I didn't hear anything from them. They were just using it and it worked. So that was kind of cool. So I'll just do a quick tour of this. So if you go over to GitHub for any of these packages,
Tim,
there's a user guide that kind of goes into detail on a technical level. For ISC REST, there's also a tutorial that has. Yes.
Can you hear? Yes. If you share the screen, you share like the page with Zoom. So it's myself basically. So if maybe you want to share another page, yeah.
Oops. Yep. Sorry about that. Yeah. Can you see the right screen now?
Yes. Mm-hmm.
Yep. All right. So I just wrote up this post on the developer community that has pointers to all the relevant things and a little bit of information there. But there is, if you click through Open Exchange, there's a user guide for each of these in GitHub that says this is everything that you need to do to use this package. So with isc.rest, the basic idea is for your application, you define a top-level REST handler. This is like, in %csp.rest, you extend %csp.rest and then provide an X data block that has all your routes. The idea here is that the individual routes are delegated to classes that define representations of a given REST resource, where the security handling is handled in that class. Basic CRUD operations just come out of the box subject to that security handling, and you can provide access to whatever other business logic you need through a well-defined format, such that based on all of this, we can generate an open API spec. And then based on that open API spec, we can say generate client code to interact with this REST API. So what this gives us is kind of the modern REST paradigm in IRIS without having to do a whole lot of hand coding, either at that REST level in IRIS or in a client application. So right now, really our target client is Angular because we're using that internally, but it'd be very straightforward to build on what we have around that to support other technologies. And we definitely welcome pull requests for that. So ISC REST handles the REST stuff. ISC.ipm.js really allows the IRIS the InterSystems package manager, ZPM, to really make it easy to build and deploy these modern web UIs. So you're not stuck with CSP or Zen or a vanilla HTML, JavaScript, CSS application, or needing to do something like check your build artifacts into source control so that someone can just install your package and they have everything running without needing to go through the full build process. So what this package does is it just provides a number of utilities for supporting Angular's path location strategy in a web application without needing to do funky web server configuration, or also being able to drive Angular build and deployment to a web application in IRIS so that you can have an Angular UI as part of your full stack application. And again, if you want to say support React or whatever, be pretty straightforward to add a build process for that as well. And I'd welcome PRs and feedback. I'm happy to help with that process. And also this makes it really easy to generate your client code. So you just set up a little bit, and I'll show you what this looks like. In this demo application, that's just an Angular UI wrapping the line-by-line monitor. In module.xml, I've got, so in my package, I have ng/monlbl-viewer is an Angular application that is the UI in my full stack application. I've got classes, and I've got an openapi.json file that is generated using the package manager. So in module.xml, I say I've got my classes, I've got this package. I'm going to zoom in a little bit. I have my Angular UI, and there's a thing that I put in to say process that, and we'll deploy it to /CSP/ whatever the current namespace is /monlbl-viewer. Then there's a standard CSP application processor to say copy all those files over that were generated by doing that Angular build. And there's a REST handler to say support the path location strategy. So instead of index.html #/some_route, it's just /some_route under that base web application. There's my REST API, which is just in a /API application under that same path. And then this block says generate OpenAPI for me based on this REST handler class, this web application, this base URL relative to my web application path. And we're also going to generate a TypeScript Angular client with a bunch of additional properties. And this is using another open source tool, OpenAPI generator. It's, I think, fairly well known in that area. And we'll generate our client source out to this path relative to the package root. And it's as easy as running ZPM package name space generate, and it'll just spit all that out for you. The OpenAPI spec in JSON and whatever client code you want to generate using this structure.
Tim, may I have a question here?
So again, this application is just a nice sample for how it all fits together.
Can you hear me, Tim?
Yes.
I may have a question on the go. So I see target folder generator and additional properties attributes to CSP REST application.
Yeah.
Is it something out of something extension attributes. How does it work? So because I think they're not like typical, yeah. So what?
Oh, now that I'm realizing there's kind of two different ways to do this. There's this attribute name value could actually be represented a little more tersely in ZPM with this as an attribute of the resource. Basically, within the package manager, you can say for any named resource, which would normally just be some file or folder within your package, I have a class that says when in the reload phase, in the compile phase, in the activate phase of the package manager, this is what I want to do with that resource. And we add down here, by using a different lifecycle class, we also add a generate phase. So this class says in the generate phase, generate that OpenAPI documentation.
Okay.
In the client code. So that's not something that normally runs when you install the package, but it's an extension to the package manager to say you can drive this easily through the package manager CLI.
Okay. Okay. Thanks.
And I would say it's just helpful, like in almost kind of our traditional Iris centric, the server or the Iris instance is the center of your application universe view. This fits with that, but it also just fits with the simplicity of building and deploying as a single unit where, you know, you're running in an Iris instance and you say, install this thing, you should be able to get a UI too. Any questions on that? I feel like as a developer, my preference would just be look at something where it's already working and copy that pretty much. And that's why we have this. Well, it's a useful package in itself, providing an Angular UI and REST APIs to interact with the line-by-line monitor. But it's also a useful example of how all of these things fit together.
Thank you, Tim. Colleagues, any questions to Timothy? I would add that we introduced two technical bonuses related to these packages to IC REST. And yes, so Tim, thank you. So I will share my screen and go to bonuses section now.
I'll let you take over. Yeah.
Yes, can you see my screen? Colleagues, please confirm, anyone, if you see the page with.
Yes, I can see the page.
Okay, thank you. Yes, as we here are the bonuses that developers will have in this contest, and here we have a climate change bonus. So if your application is related to tackle or to help to solve global warming and climate change problem, so you will have like 5 points. And if your full stack application will include IC REST package and IC IPM JS packages, you will get 2 points per each. These are exactly the packages Tim demonstrated you now. Don't hesitate to ask any questions related to that. And also, we encourage developers to use embedded Python in their full stack applications and adaptive analytics or at scale. Also, as usual, we encourage developers to use Docker in the repository to run. This will ease test and run, and also it will ease the collaboration to this project, because with Docker, it's so easy to get it working and start collaboration, like with pull requests or for example. We also encourage using ZPM or package manager to package your application, so it will definitely ease the deployment of your package to any IRIS that has a ZPM client. And some other usual bonuses like online demo, unit testing for ObjectScript, articles in community, quality check for ObjectScript, and and YouTube video. So basically this is it. And speaking of like climate change bonus, we don't limit you with focusing only on this problem. You can contribute in this contest any full stack application that uses InterSystems IRIS on the backend, and anything else like any front end like Angular, Vue, React, or just jQuery, or anything else, maybe some desktop.NET application, Java, whatever works for you. So you are welcome. But if so we have some question. Okay. Any questions so far regarding technical bonuses? Okay, no questions. I think so. We will finish the kickoff. So we will let you good luck. We will wish you luck in this contest. And looking forward for your contributions. We will be having 2 weeks to develop, and 1 week for voting, where we will be able to make changes and add some features. Good luck, and let us help in solving climate change problem with the InterSystems technology and open source contributions. Thank you. Have a great week.